Today, we're fortunate to have Kate to give us invited presentation. She's a senior research associate with the North Gulf Institute at Mississippi State University in a corporate institute for NCEI. She develops GIS product and tools, and recently she has started working with thematic resources. And here I linked in the meeting notes some additional background she has. And without further ado, I'm going to stop sharing and hand it over to Kate.
Okay. Share this. There we go. Thank you, Peng. Yeah, so today I'm going to describe how I transformed CMECS into a fair vocabulary that conforms with the 10 simple rules that were devised by Cox et al. And published in this paper, the 10 simple rules for making a vocabulary fair. And so these rules were written specifically for converting existing vocabularies from legacy formats so that terminology is able to be unambiguously cited in data sets and data can be discovered and integrated. There are a few assumptions that go with this, and those are that there is a community requirement for the vocabulary's use in data and metadata, and that there's no similar existing resource that meets that requirement. And also, and probably most importantly, that there's a group or organization in place that acts as the content custodian. So I'll start with a little overview of the CMECS vocabulary and how it's applied, and then move on to the FAIR implementation. CMECS was developed primarily to be used in GIS mapping applications. So its organizing logic is very different from that of general domain vocabularies or biological taxonomies. So it is essentially a controlled vocabulary in that it's a collection of defined terms that are used to categorize and label or annotate data. And in CMECS, these are called ecological units because each unit defines a measurable space so that observational data values can be described and visualized as human understandable concepts. And so the units are organized in a modular framework of components and setting, and these are specifically tailored for spatially variable data types. And there are 4 components that are the core of the CMECS classification. We've got the water column, biotic, substrate, and geoform. And within each component are multi-level hierarchical lists of units describing environmental phenomena at different spatial scales and at levels of specificity. And so the rule with CMECS is to classify and use the unit at the lowest level of the classification that your data will support. And so looking at the image on the right that illustrates one of the substrate component classifications, the most general category is the class at the top level, at the upper level. And that can be used if the spatial resolution is really coarse or visibility is poor and features are hard to define. And then in that case, you would classify just all those rocky looking features with the coarse unconsolidated mineral substrate term unit. But since we can actually discern individual boulders here, you would use the subgroup unit boulder instead. And then there are subclass and group units in between if you needed either of those. So I hope you can see that this framework is used to define database schema and to create thematic GIS layers that can be used either individually or combined into more complex products. And so this group probably understands this, but labeling data adds context for understanding what the data represents. If data is labeled with clearly defined terms, then that context is unambiguous, and that's unlike the situation depicted in the cartoon. And this enables consistent interpretation so that products and information are comparable from season to season and across regions. And this provides greater accuracy for data discovery, and it supports the map once, use many times philosophy for data reuse. And it also ensures that data and information are reliable and can confidently be used in decision-making and regulatory requirements. And so CMECS was developed to support these US policy goals by providing this common language for interpreting data. And its rationale and history of development is detailed in the CMECS document, and that includes a review of the existing standards at the time, none of which met the policy goals for managing the US National Spatial Data Inventory. And so it was endorsed by the US Federal Geographic Data Committee in 2012 as a national standard. So a little bit more about how CMECS is applied. Like I said, each unit defines a measurable space, and so CMECS can be applied to any type of data to produce a descriptive GIS data set that's able to quantify habitat features. And so this table illustrates some of the different types of data that are typically collected and used in benthic habitat mapping efforts. And so this is from a study by LaFrance Bartley and others, and just showing that so it's common to use bathymetry data, which can be derived from various sensor types to identify geomorphic features, and then to also use grab samples and cores to help validate substrate type. And that results, in this case, in a map of nearshore benthic environments. This is at Fire Island National Seashore in New York, and this mapping was done post-Hurricane Sandy and is used to monitor changes and set restoration priorities. In addition to mapping, CMECS is now being used to help prepare imagery data for AI-assisted applications. Like over the past decade, the volume of video and imagery has proliferated, and annotation tools have been used for some time. The center image here shows the viewing window of this seed tube software that was developed by Ocean Networks Canada. And on the left is the annotation panel with CMECS terms embedded in pick lists so that the imagery can be easily tagged by an analyst at the timestamp of where the feature appears in the video or the image. And so using these terms with verifiable definitions for the annotations provides clarity and context so that the data of interest is easy to find and use. But there's a lot of footage, even in a single dive. And so it's tedious and time consuming for humans to annotate this. So there's a really big push to automate this task. And so the image on the right just shows a little output from an AI tool. I think this is from Tater, where the AI has identified targets in the image that are then annotated and used as training data for the algorithm to sort of like feedback and model, so that then it can hopefully apply the correct annotations, identify targets and apply the correct annotations so that people don't have to do this. And so when turning this task over to AI, it's even more important than ever to use verifiable sources of information so that the outputs are trustworthy. And so CMECS was developed as a dynamic standard, and so that just means that it was designed to be updated so that it remains relevant and useful. And the first of the 10 rules is to identify the content custodian, and for CMECS, that custodian is NOAA. It's actually the NOAA Office for Coastal Management that coordinates the CMECS implementation group, and that is an interagency group made up of many of the original developers of CMECS, and others from the user community. And we promote CMECS and provide guidance and developed the update process and governance criteria we're responsible for reviewing and evaluating any proposed changes from the user community. So they had mapped out this multi-step process, sort of like shown over there on the right. There's different pathways for different types of changes and various points of like review and evaluation. But we didn't really know what to do after a proposed change had been accepted, other than we knew that we needed to somehow update the existing resources and disseminate this information out into the user community. And so CMECS existed in a variety of non-web ready, semi-structured legacy formats. There was a CMECS document, the standard document that had been published by the FGDC. We also have the CMECS catalog database, which was an access database that had like all of the units, the terms and definitions, relational tables. And then there was a web-based search tool, the CMECS catalog for vocabulary search tool, but unfortunately that was decommissioned due to lack of funding, but that was very popular with our user group. And then we had various structure tables in Excel and Google Sheets, but totally unregulated. So that wasn't a great situation. But we knew that we couldn't just replace those because now we had like these additional requirements. We needed to be able to track and document changes in a way that is like open and transparent so that it's easy for users to see what's changed. And then we also needed to be able to publish new versions in various formats because our users have different skill sets and levels of technical skills. And we also were hoping that we could set up a new source or a new browse search tool. So I learned a little bit about SCOS and ontologies from colleagues and from Google, but I eventually found my way to ESIP. And I owe a huge thanks to everyone in these clusters, semantic harmonization, semantic tech, and the biodata clusters for getting me started with the resources. I've listed some of them on the right there. And some of these are also included in the 10 rules paper. But they got me started with those resources, and they involved me in their various projects, such as working on Envo and Suite and the core. And so that gave me some hands-on experience with the tools and platforms. So I was actually already pretty far along by the time I found the 10 simple rules paper. But I'll say that it has been so helpful to have all the principles and methods compiled into a single source and have them thoroughly explained, and to also frame this like within FAIR, because that's a really effective way to communicate the concepts of open and connected data with also, I think, like these semantic technologies for somebody who's not an expert in those. And so what's really helpful is to have like these 10 rules, and this is what they look like. And I've sort of turned this into a little bit of a checklist for CMECS. Rule 1, we have the CMECS implementation group is the custodian, so we check that box. We have a license because CMECS was developed using federal funding and it's managed by NOAA. We're licensed under CC0. The term definition and completeness is ongoing, I'll say, because even though each term does have each ecological unit has a term and a definition, but we're going through this comprehensive review, which is like the first time since CMECS has been published in 2012. But so part of that review is going through and double checking the completeness and consistency and making sure that it's still up to date with current scientific practices. And so we're doing that incrementally, sort of component by component. So that's ongoing, but it's part of our process. We've established a traceable maintenance environment using GitHub and Zenodo. We've assigned unique and persistent global identifiers to both the terms and the vocabulary. So I've set up permanent URLs with w3id.org. We have machine readable representations of the vocabulary terms. That was achieved by converting all of the ecological units and other information and encoding that in an OWL SCOS file. Adding vocabulary metadata is ongoing, as that's also part of that comprehensive update that I described for the definitions and terms. And the vocabulary is registered on the EcoPortal ontology repository, which is an open source, so free to do that. And the vocabulary is accessible for humans and machines because the persistent URL set up with W3ID resolved to EcoPortal HTML pages. And we have implemented a process for publishing revisions using GitHub, Zenodo, and EcoPortal. And so this is just a screenshot of the CMECS catalog or the CMECS OWL file in the Protege desktop editor, which is what I used to encode CMECS in OWL and SCOS. And I used the integrated selfie plugin to import all the terms. Up at the top, you can see that the w3id.org persistent URL is listed there. Oops, we've got the license information clearly stated. And then SCOS and OWL encodings for other metadata such as version information and additional resource information. And then at the term level, each term is assigned a unique opaque ID. So those are those codes, and those are appended then to the URL. And so these are dereferenceable. So each term URL resolves then to the page on EcoPortal. And each term has a human readable, there's a searchable, unique human readable term for each unit. Also a definition, and these are encoded then in SCOS and OWL so that they're also like machine readable, and you're able to reason on these terms, and there's the relationships as well. And then we've also included term provenance information, so citations for where we've taken these definitions from the literature. Or sometimes if we have like other contextual information, we provide citations for that as well. And then some other like CMECS specific metadata and annotations. And so it is entirely possible to do this and to convert your vocabulary without knowing anything about like coding and XML and all that. You just kind of work through the interface here in Protege. But I will say that like these days I do actually go into, since we have the file on GitHub, to just edit directly the code in the editor, the integrated editor there. But so these are the CMECS linked resources now that help, that allow us to document the changes and provide transparency and continuity and access to CMECS, but also like the other artifacts. And so we have the CMECS catalog OWL file, and so that's managed in GitHub, outlined in pink there. We use GitHub for documenting issues where community users from the community can create issues for us to review and deal with. So we use it for documenting issues and version tracking, and then packaging the versions and releasing them, providing access to those packages. And we're also able to provide detailed release notes that go with that. And then a wiki that describes documentation and other processes. And so each release package is archived on Zenodo. And so that's sort of like outlined there in green. And Zenodo is an archive. GitHub's not an archive. It's a repository, but not an archive. And so Zenodo also issues DOIs for the vocabulary as a whole, and then for each version that we publish. And so that just makes it really easy to cite and refer to a specific version. And then each of those versions is also registered on the eCoPortal ontology repository. And so, like I said, there's an HTML landing page for the CMECS catalog itself, and then individual pages for each term, along with browse and search features. And so that's really like the end of my slides. And so this is like a list of the CMECS implementation group members, and a link to the NCI CMECS page that has links to then all of the resources, I think, that of our linked resources that I just showed here too. But I thought that I would maybe try and get out of here and just show you what it looks like in a browser. Can you see the browser window?
Yeah.
Okay.
Maybe zoom in a little bit.
Let's see.
View.
Yeah?
Yeah, good.
Bigger?
That's good. Thank you.
Okay. There's a lot of white space in all of these, I think. So this is our GitHub repository where we have our files and our different like version artifacts there on the code page. Releases are accessible. This is the latest version. So this is like the release page where we can include like a lot of notes about what's changed. And there's the wiki, which I've tried to make really descriptive because a lot of people have a hard time like navigating around on GitHub. And so I usually direct people here to start with. And so we have a lot of just background information. Most of this is already in the CMECS document. We have links to that as well, but we are also describing how we process the releases and what different types of unit metadata mean. And let's see, how to cite is helpful for people. And I don't know why not all the badges are rendering, but you can click on the DOI badge and that takes us to Zenodo, where you can access the archived versions here. And then browse CMECS on eCoPortal. So there we go. This one takes us to the catalog summary page. I'll zoom in on this one a little bit more too, because I feel like it needs it. So this is the summary page here. Basically, you just open up an account with Eco Portal, and you can upload your file. There are certain namespaces that they like you to use so that all of the information renders correctly, but they provide instructions on that. And it's not difficult to do, but you can just have like your general information here, and so there's great bits of data from the file, and give you some other metrics here as well that are calculated. And there are download links here as well for each version. And the classes tab is where you can actually go to search and browse the different units. I was going to go to the substrate because this is the one that we've done a review on already. And just take a look at, say, biogenic rubble. Up here, you can see we've got the W3ID registered URL with the unique term ID here. And so that's the persistent URL. And but there's also the EcoPortal URL, so which is the actual URL for this page. But just to show you that this does indeed redirect like magic, not like magic, but but yes, so each term URL does redirect to its page. If you click on raw data, then you can also access some of the other metadata that helps people understand what the status of the unit is, if it's changed, and what kind of changes were made to it. So yeah, so that's all I have, and I guess I would take any questions if you had them.
Thank you so much for the excellent presentation and the demo. Wonderful presentation. Anybody else? Anybody have a question? I don't see any hands up. Okay, if you go back to the slides that has the 10 rules for the fair
Oh, sure.
vocabulary. So
Yeah.
for the sixth one, for each terms, for this particular catalog vocabularies, how long did it take? Did it take a lot of effort, or yeah, that one, for each terms? Do you have
Yeah.
any idea how many terms, if I may ask?
Yeah, we have I think there's like about 1400.
1,000?
Let's see, where did my cursor go? This is kind of helpful. I go to the summary page. This will tell you here, 1,690 classes. Not all of those are the units themselves. We have other classes that are assigned for other things. But so it's I think it was about 1,500 units altogether. I should know this.
Okay.
I used to, but
So
I don't.
for that particular one, did it take a lot of time and effort, or?
Yes, I will say yes, it did. But so we had, it's like I said that we had the Microsoft Access database, right?
Yeah.
We also had spreadsheets that had just been in use for a while, right? That had like each of the units, just kind of structured that way with their definitions. And some of the other information, but I did have to then work on those sheets to begin with, so that I had like an Excel sheet, and then that had all of the information that I wanted to import lined up there and included in the sheet, and then use this plugin. Let's see. I'll show you. This is similar to what I was working with, so that we had, and I had to do a little bit of work as well, taking like an export from the CMECS catalog database and some of the existing spreadsheets, and merge a lot of information together. But basically, we'd have showing the different levels of the classification with a component, And then this is a class, a subclass, and so on at these different levels. And so then that's the term, and then a definition. Oops. Is that showing? So I had to get everything into this format and then work in with the Selfie editor, which is like a little finicky to do that. And so it did kind of take a while, but it wasn't, but I did not have to enter every term manually into Protege.
Okay.
At least I could do like a batch of transferring all that information. And then there's like some refinement that needs to happen and still needs to happen with a lot of the terms. Indeed. So that's just like an ongoing process until it's actually like really matured. But there are other tools that you can use. And I'm sure, you know, this was even probably like about 4 years ago, I think, that I started doing this. I'm sure that there are other tools out there now that make it a lot easier. And I know that that the Obo Foundry publishes these robot tools, and they're a little bit specific to, so Obo wants their ontologies to be structured in a certain way and use certain like namespaces and things. But that is a tool that also works with spreadsheets and transforms them into an OWL file, which you can then import into Protege. But yeah, it's probably worth taking a look and doing a Google and seeing what other methods there are for doing it. I mean, there are other resources that have been around a while for SCOS, such as like SCOS Play, which you can import, where you can import a spreadsheet and that will like render it in SCOS, and then you could take that and import it into Protege if you wanted, or and then build on that. So, but it does still kind of take a while to get everything kind of uniformly and encoded. So
Yeah, but the key point is it's doable.
yes,
Definitely help to improve the quality as well as the discoverability part, not to
yes,
mention the interoperability. And that's where we're going to go. Thank you again. Appreciate it.
yeah.
And any other question?
Yeah, I had a question.
Go ahead.
Thanks for the great presentation, Kate. This was really nice to
Sure.
see. Um, I'd like to understand a little bit of what the user landscape looks like and how people are integrating CMEX terms into their existing projects and works, just to understand a little bit more of what that landscape looks like, if you know about that and can speak to it. Is it people at the repository level who are directly integrating with these like W3ID URLs? Is it individual researchers who are like taking preferred labels and using those in their spreadsheets, or using these actual URIs in, raw data sets that they're creating? It'd be great to understand a bit better of what the different usage patterns looks like for integrating and making use of CMEX terms.
Yes. Well, like I said, like people use CMEX in various mapping applications, and I think maybe I'll just here's another. If you wanted to, where is this? We have, I'm just showing off now my all of the different products that we have. So,
Great.
but it's actually been sort of like recent. I mean, can you guys see this webpage now?
Mm-hmm.
Yeah. So we have this little map application where we've listed that lists like user projects, like, because we as the implementation group don't do necessarily don't control a lot of the research that's going on out there. This is a public resource and people can use it however they want. And so these are the resources that we know about, that we just kind of add here with links back to the projects and a little bit of information, so that, if somebody was interested in something like, oh, how is this applied to my area? Or you can search by, the various components and things like that. So that's a little bit of like, you can see how widely, it's used in what different applications. But I will say that like using, integrating the actual URIs and things like that into projects, I do not know of anybody who is doing that yet, because this is fairly new. And
Hmm.
I'm still trying to like get the word out for this. People might maybe doing that, but I'm not actually sure. But I think that, for instance, the C-tube video annotation tool that I showed, they just updated their interface, and because we had also made some changes to the substrate component units. And so I'm not sure if they've done this this time around, but they can in the future, where they list, these terms, and they can just add it directly into the metadata, the persistent URL, right? And so that it's always referencing back to that. And I think with the automated machine learning tagging as well, that they may be using that. But I don't have a way of really tracking that at this point. But I would say, if people are using, I would love to know. I would love to have like a documented example of that because I think it's really new. And so, working with the biodata cluster, been learning a lot about OBIS. And so OBIS is, I don't know if you know, but it's a global database of biological occurrence data. So they use Darwin core metadata to document all of the samples that the sample information that they include in their database. And so Darwin core allows you to include things like extended measurement effect, where the data managers put in, if there's available information, they can add in information about the environment where that organism, where that species was found. And so I was like, oh, well, you guys, if you need to, like, I know that there are NOAA practitioners who are using CMECS in their data that they're also uploading into OBIS for discovery. And so, now you can add in, and so they weren't using CMECS in OBIS because we did not have dereferenceable IDs for our terms, but now we do. So I'm trying to get them
Great.
to use that more often. But those are sort of like early days. But that's another like example of how and where we can increase that use. So
The project that you showcased, the ArcGIS like mapping thing, is that a like those annotations, is that all managed centrally within NOAA and by like the NCEI group? Like
yeah,
these
this
real
is oh yeah, this is an application that I actually built. It's just like an Esri sort of like out of the box application a
Mhm.
little bit. It's like I don't know, experience builder if you have any experience with that. But and we're getting ready to sort of to upgrade it soon. That's kind of in the works. But yeah, so but it's sort of like a product of the implementation group, because this is kind of how we source a lot of the information, where we have like people who we know are practitioners, or the people at the Office for Coastal Management who collaborate on projects pretty much all over the nation, for mapping habitat for various projects and applications and things like that.
Mhm.
So a lot of that information comes through those partnerships,
Mhm.
that we just sort of like know about. And so so if you know of anybody who uses CMEX and just wants to get their point on the map, that would be really great. All they have to do is send us an email, and there's I think that we even
Do you work at all with the OCADS team, or is that a use case or a group that is thinking about adopting this into any of their like metadata, the ocean carbon acidification data system?
yeah, no, I do not work with them
Okay, I
and
do.
have not, but I'm familiar with that.
Yeah,
And the CMEX, like in the water column component, utilizes some of that. But it would be great to have
I'll
actually
make
input. Yeah,
yeah,
for
I'll make
people.
sure that they know that this is all available and stuff, and if it makes sense to point them in your direction, I'll connect them to you. I'm happy to do that.
Yeah, that would be great.
Linus Cam is the one who I'm working most closely with, and he's at PNNL.
Okay.
Yeah.
Um,
That's
yeah,
good.
although just
Yeah,
if
that's a good
we needed to go
question.
to that. Yeah.
And I don't believe, Kate, you have issue to share your slides. I can link what you have sent me into meeting notes. If you would like to make changes, let me know. I can always do that afterwards.
Okay. Yeah, that's fine. Do you want me to provide like a Google Slides version or something instead, or I could upload it and share this with you? If
I
that's easier to
uploaded,
share or not.
I look at it, it seems to be okay. I
Okay.
look at it on Google, so they should be
Oh
fine.
yeah.
Yeah.
Okay.
I like the link you showed for the CMECS in action project list. Is that in
Mhm.
the slide? If it's not, if you don't mind, put the link in the meeting notes. It would be great.
Oh yes, I will. You
Okay,
can get to it
wonderful.
from the webpage, but yeah. So we'll do, but I'll put that in there too. So
Okay, it
that's
might
what
be easier
usually
just
takes
get
me
the
off on a
link. Yeah.
tangent. So I try not to do that if I have just a little bit of time, but
Okay. Maybe quickly, Marcella has a question in the chat. In the wipe map, the best way to find data for each of the components of the vocabularies.
um, it's a good place to start. And like I said, it's like we don't have a central repository of data. Um, So this does, you have to go through like a couple of different steps, I think, to find the data. So, if you wanted to look into projects that use the geoform, you can filter them using one of um, the filter down here, which is just like a toggle button. And then you would have to go to um, look here. So, and I know that this is, and then you can go down here and go to their data access or more information. And so this takes you to the actual like data provider's access point for data. So that's a lot of steps, I know. So the new version of the application that we're going to put out has like a table view, which makes it easier to sort of like look and get through all the steps. But so this is like a good resource. But I will say, like my colleagues at the Office for Coastal Management, Benthic, just in the past couple of weeks released this Benthic Data Hub, and I'll put this into I'll put the link into the chat, but I'll also add this into the notes, Peng. So
Oh, that would be great. Yeah.
yeah, so this is a very new resource that they set up, and so this features a lot of the NOAA CMECS NOAA work that uses CMECS. So and that will actually take you to, oh, these are just screenshots, but you can look and go here and look for the map. Anyway, I don't know this well enough to take you directly to a data set right now, but let's see, training stories, resources, topics. I think that just goes to Digital Coast altogether. But there are other resources where you could just maybe, type in CMECS or and see what you get. But I'll put all those in the notes for you, like I said.
Okay. Thank you.
Yeah.
And feel free to reach out to Kate if
Yes.
you have additional